Hello, everyone. My name is Liberato Santos, and I would like to welcome all of you to our first Assessment SIG in British Council webinar in our webinar series. This webinar was organized by a partnership between the Brastisol Assessment SIG, the British Council English and Exams Area, and the British Council Assessment Research Group. In that regard, I would like to thank a few people: Dr. Mariano Felice from the British Council Assessment Research Group, who kindly accepted our invitation to be our guest speaker; Tassiana Silva and Ana Luisa Marques, here representing the British Council English and Exams Area; Sergio Monteiro, Andrea Poppe, Gabi, Tony, and Diana, here representing Brastisol; and last but not least, my colleagues in the Assessment SIG, Gladys Quevedo Camargo, Douglas Consolo, Isadora Moraes, Ana Lígia Silva. Thank you all very much for the teamwork that has made this webinar possible. Today, we will be discussing AI, artificial intelligence, and how it can be used to solve different tasks that can support language teaching and assessment. Our agenda for this webinar, we're now doing our roughly 5 minutes opening. Dr. Felice, our guest speaker, will have 40 to 45 minutes to present. That will be followed by a 10-minute Q&A session. Please feel free to type your questions in the chat. We'll be reading them and trying to collect as many questions as possibly can be answered by Dr. Felice in 10 minutes. And then we'll do our closing the last 5 minutes. I will now briefly introduce our guest speaker. Dr. Mariano Felice is a senior researcher and data scientist for language assessment and learning at the British Council and a visiting researcher at the University of Cambridge. Dr. Felice leads work on artificial intelligence and natural language processing for language teaching and assessment, and is a regular speaker at international conferences. So without further ado, please welcome Dr. Mariano Felice.
Hi, everyone. Well, thank you very much. That was a very warm welcome. So I was going to say, well, good morning or bom dia and good afternoon for me. So let me share my screen so we can get started. So can you confirm that all of you can see this?
Yes, we can. We cannot see you though, but we can see your presentation.
Yes.
Oh, okay. That's tricky. Okay. I think my camera should be on, but anyway. Okay, so in this talk today, I would like to talk about some foundations of AI, because I think, sometimes people are not really aware of what is going on behind the scenes when we talk about AI, how systems are built, how data is collected, and so on. So the idea is to demystify what happens in AI systems, basically. So I'd like to begin by answering these questions. What is AI? So one definition that I really like is this one. So it says artificial intelligence is the ability of computers to perform tasks that are typically associated with human intelligence. And what that means in practice is that AI tries to solve tasks that generally require some sort of reasoning, understanding, and inference. What this means is that we're not talking about solving tasks that are very easy for a computer, like could be things that require computation and so on, but more abstract tasks that are the kind of tasks that humans typically do. So they require some abstraction, some understanding of language, some understanding of the environment, vision, and so on. So why would we want to use AI in particular for education? So there are many benefits to it. So for one, for example, time saving is a real advantage. So we can delegate lots of things to the machine, and that would give us more free time to dedicate to other things. We can also obtain fast results. For example, if we do something like automated scoring, we can get, the results of the tests very quickly. There's also constant availability of these systems. There's no need for a teacher or an educator to be, online all the time. Then we also have the ability to create creative and engaging content by use of things like nowadays ChatGPT, for example. Then there's also the benefit of automation. Again, lots of things that we do manually, we can delegate to the machine. Also, the ability to generate things on demand. So, for example, if we think of things like generating exercises to practice a particular aspect of language, these exercises could be generated on the fly. That also ties in very nicely with personalization, so we can make a machine adapt the content that it shows a user based on their past behavior and performance. So it makes it very easy to adapt the content to their needs. And also it allows us to get insights from all the data that we collect, be it from exams like exam results, but also, as I mentioned, from the behavior and the interaction between the candidates, the users and the machine. So how do we actually go about creating this artificial intelligence that powers all these fancy systems? So there are basically two ways in which we can do this. So the first of these ways is what I call symbolic methods. So this is a rather old-fashioned way of doing AI. So in this case, what we do is we get together with experts in a field, and we try to encode the knowledge about how to solve a particular problem by means of rules, basically, or some sort of linguistic representations or easy to read representations of how a problem is solved. So you would sit down normally with let's say, I don't know, a doctor, for example, and then the AI practitioner would elicit information from this expert and try to create a series of rules that would tell the machine how something should be solved. So in this case, all the knowledge that we are integrating into the machine is given by the algorithm, is given by everything that the AI practitioner writes. So if we could think of an example, let's take the case of a system that would diagnose a health condition, for example. In the early days of AI, some of these systems were called expert systems, precisely because they were trying to emulate the expertise of professionals in a particular domain. So we could think of, for example, an example rule for one of these systems as something like the example we see on the screen. So, for example, if we want to detect whether a patient is likely to have pneumonia, we can have a series of conditions, like if patient has a fever and they have a cough and they have difficulty breathing, then this is a likely condition. But just like we can build rules, we can also use some well-known algorithms, for example, for things like search. So if we want to find the shortest path for example, from point A to B, then we do have ready-made algorithms, tested algorithms that would solve this problem. So again, all the knowledge that is required to solve a problem is given by the algorithm, is given by the code that is written by the AI practitioner. Now, for things like language, which is of interest to us, writing rules, for example, for assessing good use of language or detecting grammatical errors and so on, it becomes really cumbersome and time-consuming and very difficult to maintain. So we need better ways of putting in this knowledge in the machine. So the method that is more efficient to do this kind of thing, to solve this kind of problem, is machine learning, which I'm sure you've heard of before. So in this paradigm, we don't need subject matter experts, and we're not writing any rules. Instead, what we do is we make the machine learn how to solve a problem by exploiting examples where this problem has been solved before. So this allows us to solve virtually any problem because we only need labeled data. So in this case, unlike the previous approach, all the knowledge is in the data, not in the algorithm itself. Although, of course, we need special algorithms that are the ones that are able to learn the associations from this data. So some of the examples that I'm sure you've heard of before. Things like automatic speech recognition. So, these systems where speech gets automatically transcribed into text. So this is a typical example of a machine learning problem. So you would collect lots of examples of audio and their corresponding transcriptions. And so you could build a system that then can do the same for new audio files. Machine translation is another typical example. So in this case, you just need to collect many different examples of translations from language A to language B. You feed that into a machine, and the machine will learn how to translate new texts. And then you can do more sophisticated things like, for example, detecting classes or patterns in data. So for example, in this particular case, differentiating a dog from a cookie. And I know this might be a silly example, but it just goes on to show the ability to which we can make machines solve virtually any kind of problem. Now, when we talk about machine learning, there are basically two strands. And the first kind of problem is what we would call supervised problems or supervised machine learning. In this case, we're talking about problems where we have labeled data from which the machine is going to learn and predict an output value. So the idea is we have examples and we have the corresponding labels. We have the output that we expect for that particular example. So typical cases where we would use this kind of training or modeling is, for example, to detect if an essay is written by a machine or generated by a human, written by a human. So this is easy. You just need to collect different examples of essays written by a human and essays written by a machine. And because you do have the labels for each of these ones, it's very easy to get this information to a machine, and then the machine will understand to classify it. Then score a piece of writing automatically. That's what we often refer to as automated essay scoring. So the same thing, you collect a number of essays and their corresponding scores, and the machine will learn how to predict scores for new essays. And then things like, for example, classify students by proficiency level. You could associate student performance or some sample writing or sample speech or the way they solved certain exercises and associate that with CFR level. So by having these examples, again, you can build a system that would do the same for new examples. In the case of unsupervised machine learning, we use this kind of approach when we don't have labels for our data, but rather we have a massive amount of unstructured data from which we want to gain some insights or maybe find some patterns. So let's say that we have a big collection of the performance of certain students on a particular test, then we could maybe find similarities between students or detect areas where students struggle the most. So again, in this case, we don't have labels for the data. There's nothing that we want to predict in particular, but rather we want to see whether we can extract some insights from the data that could inform, for example, some decision making. So when we talk about AI in education and language assessment in general, we tend to think of problems that we would solve using supervised machine learning, because in general we want to predict things. We want to predict a score. We want to predict a CFR level. We want to predict whether somebody has made a mistake and so on. It's not usually the case that we are very interested in supervised learning, but that can have its applications too. But for this talk, we're going to focus more on supervised machine learning. So now I would like to propose an exercise. So I'd like us to build a machine learning model right now, right here, right now, using one of the most powerful machines in the world. And that machine is your brain. So I am going to show you some example cases with their corresponding labels. And I would like you to think what the commonalities are between these examples and try to find an association that would explain how the output is derived from the input. So I'll give you examples with some input and some output, and I would like you to spend a little time thinking about how that output is derived from the input. Then, after you think about these associations, we're going to see if that model that you made up in your mind actually applies in reality. So I'm going to show you some test examples, and we're going to see if we can solve them. So let's start with the first example. So here we have some input and we have some output. This is the first example. I'm going to show you the second, and then a third example, the fourth, and the fifth. So these are all the examples that we can see. So I'd like you to think if you can find any association between the input and the output, and build a model in your mind of what might be going on and how you could solve a new unseen example. So I'm going to give you, I don't know, a minute or so, or maybe 30 seconds to think about it. So again, think about what associations could exist between the input and the output. How you could generate new output if I gave you some new input. Okay, so I hope you have a model in your mind now. So let's see if that model that you built in your mind actually works. So I'm going to show you the first test case, and I'd like you to tell me or write in the chat window what you think the output is. So for this one, what would be the output? Okay, I see everybody agrees that it's 4. It is 4, yes. How about this one? Good. And the last one. Okay. Okay, I see some different results. Okay, so in this case, the output is 7. So indeed, I think some of you really understood the association between the two, the input and the output. So you're basically adding up the positions of the blue squares. So congratulations, you just built your first machine learning model. So if I'm honest, I mean, there's not much to it. This is the basic concept behind machine learning, and you just did it yourself. So that's great. So what's next is now trying to formalize what you just did, but in terms that a computer could understand. So let's see now how these models are built, how we can make a machine, build a representation of how to solve a problem and use that model, that representation, to predict new cases. So the process that we usually follow is what you can see on the screen. So it's a series of steps. This is simplification, of course. You can make this process more or less complex as you need. So my idea now is to go through each of these steps briefly. And for that, I'm going to use automated essay scoring as an example. So we're going to see how we would build an automated essay scoring system using all these steps. So the very first step is what we call the data collection. So in this step, we basically have to collect all the examples with the corresponding labels. In the case of essay scoring, this means collecting essays and the corresponding scores. Once we have that collection, which should be as big as possible, because the more data that you add to a system, the better that it's going to learn and the more accurate your predictions are going to be. So once we get this big collection of data, we split it into basically 3 sets. So the first set is what we call the training set, and it accounts for something between 70 and 80% of all our data. And that is the set that we're going to use to build the model, to build the machine learning model, to teach the machine. This is the main collection of data that we will be using. Then we will have a smaller set that we call the development set. That is roughly 10% of our data. And that is some data that we set aside to tweak the system, because every time that we build a system, we don't get it 100% right straight away. So we have to start tweaking some things in the models to make them more accurate. And for that, we're going to use this development set. And finally, we will have a third set that we call the test set. And in this case, we will use this data to compute some final performance of our model. That is the set that will allow us to compute a metric, a performance metric, from which then we can say things like what the accuracy of our model is, and use that as a reference. So we can then say things like, okay, our model is 90% accurate at giving scores to essays, or it has a precision of X, or it has a recall of something else. There are different kinds of measures that we can use, but for the sake of simplicity, we'll talk about accuracy. So the problem that we have now that we have all this data is that all of these examples are not directly usable by the machine. So a machine doesn't understand images or video or text. They only understand numbers. So now we have a challenge, and that is we have to represent everything that we have in our collection as numerical values. So we have to generate a numerical representation of all our essays in this particular case. And in order to do that, we have two ways in which we can do it. So one of them is by extracting features, defining and extracting features that we can identify in our data. And this process of defining features is a manual process that typically the AI practitioner would do together with someone who is an expert in the field. So the idea here is that we would identify things that are representative in the input and that we can easily compute, things that are measurable. If we don't do that process manually, we can do something automatic. This is what is called deep learning. This is a process by which the machine tries to identify these representative features itself. Although this is a much more complex procedure and in general it's not very transparent. So when we define features, we have control over them and we can to some extent explain why we extract some things, why we've chosen some features and why not others. But if we use deep learning and we just let the machine define these features, then there's little that we can do to interpret why the machine has chosen certain things in the input. So in particular, for education, we tend to use feature-based models. So models where we define how we want to represent the data. So if we think about an essay and the kind of things that we can extract from this essay that are measurable and that we can compute easily with a machine, things that we can easily turn into numbers, I'd like to ask you again, what things could we extract from an essay? What numbers could we compute from an essay that would be useful for representing what an essay looks like? What kind of features do you think we could extract from an essay? What things could we count? So feel free to write in the chat window. Okay, so the range of vocabulary, number of words or characters. Yes, these are things that we can count. Number of spelling errors, absolutely, yes. Number of words, yes, the length of the word count, yes. Paragraph count, type token ratio, grammar, yes. So as you can see, there are lots of things that we can extract. Some things might require other models. Some things are not easy to compute straight away. But in general, we can think of many things that we can either compute directly or build other models in order to be able to extract them. So for example, in this case, if we're thinking about coherence and cohesion, we don't have like a ready-made measure maybe that we can extract straight away, but we could build another AI model that can give us estimations for these aspects. So what doesn't exist, we can always create in some way or another. So this is just a set of features that are typical in an essay scoring model, but there are plenty more that we can think of about and incorporate. So now we have a way of transforming an input essay into a numerical representation. That numerical representation, we call it a feature vector. So for each of the features, we define feature extractors. So we have to write pieces of code that actually extract these or compute these features. But once that is in place, it's going to be very easy to convert each essay into their numerical representation or feature vector. And that is precisely what we're going to use in the next step, which is the training step. This is where all the magic happens. So in this step, we basically feed all the training data, all the essays that we have with the corresponding labels into a machine learning algorithm. This is some programming code that does all the learning and tries to find the associations between the input and the output. So in this particular case, we will have all the feature vectors that represent every single essay in our training data and their corresponding scores. The machine learning algorithm will find these associations and finally output a model. So this model is the brain that now knows how to assign new scores to new essays. So the next step in the training pipeline is what we call fine-tuning. And this is something that I mentioned earlier. So the first time that we build a machine learning model, it's very likely that that model is not going to be the best model that we can get. So we have now mechanisms to tweak parameters in the model so that we can get better performance, and therefore we can improve the accuracy that we got in our first model. So in order to do that, we use the model that we just trained, and we take all the essays that we had set aside in our development set, we feed them into the model that we created, and we get the model's output. We get the predicted score produced by the model. And because we have the expected scores in our development set, we can easily compare what the machine produced with the scores that we expect. And from that comparison, we can compute a metric like accuracy and see whether that needs further tweaking and tuning. And if that's the case, because we don't achieve acceptable performance, then we start tweaking some things in the model, what we call hyperparameters, and we do this process again. We train again, and now after we tweak this model with this algorithm, we get another model, and we repeat this process. So we train, we test, and we tweak, and we repeat train, test, and tweak, and so on until we see that we can't make any further improvements, and that's where we stop. So once we stop, we go to another phase that's called testing. And this phase is very similar to the previous one in the sense that we will take all the essays from our test data, we will send them to our model, we will get the predictions from the model, and we will compare those predictions to the scores that we have in our tested. And we compute some performance, but this time we don't tweak anymore. We just do that in order to compute some final performance of our model, and have an estimation of how accurate our model is. So we would say things like, okay, our model has 80% accuracy, or whatever it is that we are computing. So once we know that and we finished with tweaking and testing our model, we use it in the real world, with the caveat that we know that our model is not going to be perfect. And say if we have something like 90% accuracy, that means that out of 10 essays that the machine will rate, one is not going to be accurate, most likely. But still, that's much better than having a human rate all these essays, especially in scenarios when we have a very large number of candidates. So I was thinking earlier today about whether I could come up with an analogy in case this wasn't very clear. And I was thinking this is probably very similar to studying for an exam. So we would first get the study materials, then we would summarize those materials, maybe make a summary or mental map or charts or whatever. Then we study from those shorter forms of the initial material. Then we do some practice exercises, and we learn new things if we need to. We fill any gaps in our knowledge. Then we maybe practice with some past exam papers, and we finally take the test that we were preparing for. So I don't know, maybe this analogy is useful to you. So now I'd like to maybe dig deeper into how we can use these models for teaching and assessment. So what can we do? What kind of models can we build? So one of the most basic models that we use in AI are models for part of the speech tagging. These are systems that would take a piece of text, and they would produce a tag for each of the tokens or words in the text. So this is all done using artificial intelligence. And as you can see here, the output would be a piece of text, and the output would be the tag text. What I'd like to do with these diagrams is show you how this maps to what we've seen before of input and output. So the output is text, the output is tags, part of the speech tags. Now, what can we use these systems for? So we can, for example, analyze word usage, analyze vocabulary, um, find common structures or errors or overuse of certain structures, or even use this as building blocks for other things. In particular, in AI, we use this as the very first step before, for example, computing features, as I showed earlier, for essay scoring. So this would be one of the most basic steps when we do data pre-processing. But this is something, these are systems that you can also easily have access to. So you can also use yourself in the classroom or for other purposes. Similar to that, we also have systems to do syntactic parsing automatically. So in this case, the output would be a piece of text and the output would be a parse tree. So this would allow us to analyze sentence structure, for example, detect unusual constructions, or even compute the probability, for example, of certain grammatical structures, which could be used to assess fluency, for example. This is also something that we use as building blocks when computing features for essay scoring systems, for example. Well, then there's essay scoring itself that we have just seen. So why would you want to use something like this? Well, because you could get test results very quickly. You could reach a large number of students remotely in different locations. And this could also allow self-learning. So if students have access to an automated system, then they could, for example, practice writing and get a score straight away. And that would be, a very useful tool instead of having to rely on a teacher the whole time. There's a whole question of availability here as well. We also have systems for grammatical error correction. These systems take a piece of text as the input, and they tell us what is wrong in terms of grammar and vocabulary. Some of them, if they are more sophisticated, they can tell us things like collocations as well. And they do not only correct text, but they also detect, in general, people working in this area, they tend to make this distinction between detecting errors and correcting errors, because most of the time detection alone is enough, especially in learning environments, because you don't always want to give the answer away. You would much rather tell the students that there is an error in a particular area of your text, and then let them think about how they would correct that. Now, these kinds of systems are also useful to get insights on problematic areas, so detect where students struggle the most, and they can also be useful to generate automated content, automated exercises, for example. So you could link the output from a grammatical error correction system into a system that does automatic content generation, so that it generates content based on the errors that were detected. We also have things like automatic speech recognition. I talked briefly about this earlier. So systems that allow you to get a transcription from an audio file or live speech. And this could be useful, for example, to generate read aloud exercises or assess and improve pronunciation. So, for example, if you make a student read something aloud, then it means that you have the original text that they are reading. So you could easily compare that original text with the transcription that you get from a system and compute what we call word error rate. So you will get a measure of how that transcription deviates from the original text. And that should give you a rough idea of whether a student is, reading things correctly. We have the opposite of that, which is text-to-speech. So we can start from a piece of text and generate artificial speech. And this could be very useful, for example, to create listening exercises, especially if we want to create something that's customized, or we want to create exercises with different accents. So there are quite a few tools out there that we can use very easily so that we can generate audio files for the text of the exercise, and then combine these, merge all these audio files into a single file. For example, that would be the audio for a listening exercise. And we can also use these type of systems for practicing and improving pronunciation. So students could, for example, write something that they don't know how to pronounce, and maybe mimic the pronunciation of the system, of the artificial system. Then another kind of system that is very popular nowadays are language models. So initially, these were models that were trained to predict the next word given a sequence of words. So you would give the machine a sequence of words, let's say the beginning of a sentence, and the machine will predict the next word. And this is very useful because it allows you to estimate fluency. So because you get a probability of the next word being the right word in the given context, you can somehow estimate whether somebody is writing something that doesn't sound natural, for example. So again, these are things that we often use as building blocks for other systems. There's a lot of information that can be gathered from these language models, but in the most simplistic form, they basically predict the next word. And these could be used by students, for example, to improve their vocabulary by getting possible predictions from the system. So if they don't know, maybe the appropriate adjective in a particular sentence, or they don't know how to complete something that they were writing, they can get suggestions from the system. So in that regard, it's also very useful for scaffolding. And nowadays, with the advancement of technology and large language models, so language models that are built on massive amounts of data from the internet, those early language models that were only able to predict the next word, now they can do that so accurately and conditioned on all the previous input, all the previous text that you have written before, that they have proved to be very useful for completing all sorts of other tasks. So as you probably already know, you could just now simply give the computer some instructions, and the computer will, or rather the large language model will solve these things for you. So you could say some things like create a text about topic X, and it will do it very accurately, to the extent that sometimes it's really hard to tell apart AI generated text from human generated text. So as you probably know, you can use things like ChatGPT to generate content automatically, summarize text. This could be used to improve writing skills, again, by using this as a tool for scaffolding, for example. So now to wrap up, I'd like to maybe give some recommendations if you're thinking about using AI. So we have to bear in mind that AI is not perfect. So we have to allow for some error. I would recommend that you don't use something that you are not comfortable with, you or your students are not comfortable with, because that could lead to some tensions. And if people are not comfortable using something, then that shouldn't be done. Listen to your students. If they don't agree, for example, with the output that they're getting from a model, for example, you should be comfortable discussing this and possibly even stop using the tools. Always ask the experts if you are curious about how something was built or how accurate it is or whether things could be changed. Also, don't forget the human factor. So even though we can automate many of the things, we might not want to automate all these things anyway. We have to remember that there are lots of things that teachers do that a machine wouldn't be able to do, things to do with empathy and patience and maybe different ways of reformulating things. So definitely don't forget that this is just a tool and that there should always be a human in the loop. If something goes wrong, there should be someone that is responsible and someone also that monitors the use and performance of these models in time. So my last final words would be experiment, be creative, be bold. You now have an idea, a notion of how these things are built. So you see that in the end, they are basically fancy computations. There's no real intelligence behind them, but that doesn't stop us from using these things creatively. So that's all from me. Thank you very much for listening. And I'm happy to take any questions if you have or comments.
Thank you so much, Dr. Mariano Felice, for this very enlightening talk. We do have several questions, and I hope we have time to go over at least some of them. Um, Tatiana and I have been looking at the questions and trying to collect them. So I'll try to um, put them together here. And okay, so first, Franklin made a comment in the chat saying he would suggest people start practicing Python. He also recommends a website called Kaggle, which Franklin says is a really nice place to learn this. We do have then a comment and a question by Hal Medrano. The comment is that this discussion about supervised, unsupervised is very interesting. Thanks for making the distinction. And then Hal's question is, would Cambridge's text inspector be an example of a system that uses these kinds of rules to detect linguistic features?
I wouldn't be able to speak for particular products, so I wouldn't know without any documentation, I wouldn't know how these systems work. I do have to say, though, that most of the things that you can find online very easily, they tend to be very simple and they tend to work on rules. So unless they explicitly say that they use some kind of machine learning, I would assume that most of them are very simple and probably rely on some rules to some extent.
Thank you, Dr. Felice. Um, I do have a set of questions that were asked by our participant, Josh. And feel free, Dr. Felice, to either choose some of them or give an overall answer to them. So here we go. So Josh said, with supervised learning for machine learning assessment tasks, question number 1, how do you establish the gold standard for the labeled test data? Question number 2, how much variation is there in the human labeling, particularly in speaking assessments? And question number 3, what about between expert-trained examiner labeling and non-expert, example, natural, not criteria-based evaluation by a speaker of that language as far as assessment of the training data?
Okay. So let's talk about data a little more. So when you collect data, you obviously want your labels to be as accurate as possible. So, and to be representative of the kind of examples that you will have when you actually use this system in production. So your training data has to be as representative as possible of the population that you're going to use the system with. So one of the things that you should do is, well, first of all, as I said, make sure that your data is representative. So that means have a good mix of people, for example, from different ages, age groups, people with different L1 backgrounds, um, um, people, I don't know, depending on how you want to build your system, maybe different genres and so on. And something that we usually do to check the quality of the labels in the data is we have some of these examples um, double marked or marked by multiple annotators, and we compute inter-annotator agreements. So we compute some sort of measure that tells us how um, you know, close the each of the ratings given by different annotators are. Do they deviate from the median, for example? So we do have some measures that we can compute in terms of the training data to make sure that it is good data for training system.
Okay, I do have two more questions from Josh, and then we will move on to other a few more questions that just arrived. So the other question by Josh is, can the algorithms also suggest specific improvements, quote improvements, when there are no errors, but increasing lexical range and sophistication of language structures would be likely to improve the automated score?
The models can only tell you things that you had trained them for. So as long as you train your model with this kind of data, then yes, they will be able to tell you that.
Okay, and the other question is, uh, could teaching systems simultaneously gather the data to establish the user learner's current level and therefore eliminate the need for exams?
Theoretically, you could. Yes, I would say that is a current area of exploration, whether we could assess someone just by the interactions they have with the system rather than by taking a final exam or something like that, like some final assessment. So yes, there are definitely areas of research that are looking into this. And we're doing this in the British Council as well, so stay tuned.
We now have a question from Pam Dewey. How can we help students improve their speaking and writing proficiency with AI, with AI?
So, well, I mentioned some of the use cases of some of these tools, and some of these things are readily available online. So things like, as I mentioned, automated speech recognition or text to speech. So you can generate listening exercises by using text to speech. You can improve your pronunciation by um, listening to some artificial voice saying something that you don't know how to pronounce and mimic that. So there are many ways in which you could use, tools that are online already to improve your listening and speaking skills.
And I think on that note, Hal Medrano has another question. Large language models like ChatGPT are trained by the web. As more and more web output is generated by AI, do we start running into problems where AI is being increasingly trained by AI rather than authentic human language?
Yes, that's an issue that has been raised lately. Yes, indeed, that's a problem. That's why now that this has become so common and everybody has access to ChatGPT and more content is generated using these tools, um, there's a lot of ethical discussion around this, and one of the recommendations is actually that whenever somebody uses AI to generate content, it should be explicitly mentioned. So you should say this piece of text, for example, has been generated using AI or partially generated using AI. So yes, this is an issue of, this is a feedback loop where the model is trained on the same thing that it generated. So one way of avoiding that is, as I said, by labeling the content that you generate, so you can then decide whether you want to include some of that in your training data or not.
Thank you. I got a question about video recording, and the answer is yes. This webinar is being video recorded, and the British Council will make it available. Stay tuned for an email that will be sent in a few days with information on how you can watch the video recording. We actually ran out of time, but I do think we have one last question that I will ask from Esteban Martinez. What would need to occur? Sorry. What would need to occur in order for the teacher's job to fully disappear or be replaced by AI? Do you think it would ever be?
I hope not. I mean, even though I am an advocate of technology, I'm not an advocate for getting rid of teachers. And as I mentioned, in my last slide, I think there's a human factor that these machines, these systems don't have, or at least don't have at the moment, which has to do with the social aspects of teaching and learning. So I think that teachers will still be here for a long time. I don't think they're going to be replaced fully, and not anytime soon, no.
Okay, we really need to go, but I think there is a pressing question there that was, is it possible to use AI to detect AI production? So is there AI that will tell you if a text was written by AI or something like that?
There is, yes, there is. And there are some services online that you can use. You just copy and paste the text there, and it will tell you whether that has been detected, and with a given probability. However, I have to say that OpenAI, the creators of the ChatGPT, they make it very explicit that these tools are not 100% accurate. So it might be the case that you paste something, it tells you that it has been AI generated, when in fact it has been written by a human. So we have to be very careful about how we use these things. So for example, I wouldn't use that in a high stakes situation, but there are things out there and they are pretty accurate to some extent. So definitely have a try.
Thank you, Dr. Felice. This was the last question we were able to ask. We are 3 minutes past our closing time. We would like to thank all the 195 people who attended, of which 183 stayed tuned, and now we're at 160-ish. This was amazing. We got some great questions and a great presentation by Dr. Felice. I would like to again thank the British Council, Ross Tisol, and the Assessment SIG for this partnership, and I hope to see you all next time. The video will be recorded and made available in a few days. Thank you so much, and see you next time.
Thank you, everyone. Bye-bye.